Hello, this is a video on Engineering Economics 2373, and this video is about present value, future value, and annuities and its computations, how they are related. Mostly this video is going to explain the concepts, and we're going to spend another video with some examples and computations. So let's first understand present value and annuities. In the previous videos we have seen how that one cash flow or one value like present value could be related to multiple cash flows that will be received in the future. A special case of this situation is when we have annuities. Annuities are when the cash flows happen on back-to-back periods, and each one of these multiple cash flows are for the same amount. When we have that situation, we can compute, we refer to those cash flows as annuities, and since this is a very common practice in business, we have special formulas that allow us to have shortcuts to compute these series of cash flows as if they in a simpler manner, as opposed to having to compute each one of these brought to the present independently. We can just, since all of them are for the same amount, we can use these formulas in order to make one single computation to compute, say for instance, the present value. Now, as you can see here, there is a period of separation between the first annuity and the present, and that's a characteristic that we will need to take care of when we properly model these cash flows in order to solve the problems. In practice, sometimes these models do not adjust to what happens in reality, but we can combine them together to solve more complex problems. So this is going to be like solving a puzzle in which we adjust the pieces that we have, the models that we have, to properly solve the complete problem. So just like we have these, we also have a relation between the annuities and the future value. Now notice that in this example and in every case, when we are using the formulas that relate annuities and future values, the last annuity happens at the same time where the future value is being computed. And this is key again, because this gives consistency to the models that we had before, because we need to count complete periods from the value of P happens, the present value, till the moment when the future value F happens. And as long as we have that consistency, we can use readily the formulas that relate P and A and F, combine them into interesting solutions. So when we look at these together, you can see how these two work. Where we have a present value here that has one period of separation from t equals 0 to t equals 1 for the instance of the first annuity, and in this example we have 9 annuities. In order for us to have 9 periods, that last future value would happen again at the same period of the last annuity. The computations that we would like to do are simply the summation of all these cash flows that happen in the future. If we want to compute the present value, we would compute the summation of these cash flows that happen in the future, brought to the present. And the formula to bring all these cash flows to the present is P given F for I and T, or 1 plus I to the negative T. And as opposed to using CF for cash flow, we're going to be using A because it's the same annuity, and actually, since it's the same annuity, we could have just used A. In the same manner, in order to compute the future value, we need to count, we can compute a future value as the summation of these cash flows A times the factor F given P for I and N minus T for each one of these cash flows. Now this would be cumbersome, or this would be tedious if we have a very large N. That is, we will need to compute these several times for each one of these cash flows, and it will be time consuming. So what we would like to do is we would like to use a formula that relates these, including the summation. Unfortunately, we have those formulas. And the formulas that we can use are depicted in this diagram or this screen. In order for us to find a present value when we have several annuities, we can use the factor P given that we know A, and we multiply that factor times A. Or conversely, or in the same manner, that formula is specified as this factor for P given A. The factor or the formula for that factor is 1 plus I to the n minus 1 divided by I times 1 plus I to the n. In the same way, we could find an annuity if we know the present by multiplying such present value times the factor A given P for IN. Now the formula, of course, it's very simple to derive. If we know the previous one, it is just the reciprocal of this formula. So we have I times 1 plus I to the n divided by 1 plus I to the n minus 1. These two are very, very commonly used in business, in every operation that we have. When you buy a car, when you buy a house, and you have to compute the mortgage, because you have to compute how much you're going to be paying per month. So if we're going to be paying the same amount per month for, say, the next 180 months, then you need to find what's the interest rate that is going to be used per month, and that interest rate would be applied here and in the formulas. And also we would need to, well, the number of periods would be 180 months, and that would allow you, if you know how much is your debt on your house right now, you can compute how much you will have to pay every month. Of course, it's an equivalent computation when you have to do the operations for the payments for a car or even the credit cards. So essentially, this is probably the most common use formula, and it's just a shortcut. This is just a shortcut, remember, to the original formula that we have when we related P given F. This formula is a shortcut for computing 1P with several future cash flows. Also, we might be interested in computing a future value given that we have annuities, and this is also very common, and you can figure out this formula very easily. You will notice that the only difference from this and the previous one is that we are lacking here the value 1 plus I to the n at in the denominator, and the reason for that is because we have taken what it was the present value and then compute that or move that to the future. So it's very easy to derive. There's a lot of applications to this formula. Say, for instance, you are willing to save for your retirement and you're going to save a fixed amount. It could be $25, it could be $50 every month, and just that amount, if you knew how much interest you will be getting in your investment, you can count how many months you will have until the age of retirement, and how many times you can save that money. And using those two factors and of course the amount that you're saving, you can figure out how much money you will have at the age of your retirement. Or also you can figure out how much you will need to save if you have a particular target as your retirement. Very useful, these formulas. So these formulas are probably the most useful and the most dramatically common in practice. So keep studying this, and I will see you in the next video.